Good morning, everybody. So, as you know, yesterday we have studied only two concepts. I think you all understand well. The first concept which we studied is regarding density. So, let me know what do you mean by density, everybody? Density is equals to what, guys? All of you? Mass by volume. Okay. And the SI unit of density, you all should speak. Otherwise, there is no. I'm not having interest to teach also. So, SI unit of density is what, everybody? Kilogram per cubic meter, and the CGS unit of density is gram per cubic centimeter. And we all studied that relation between them. So 1 gram per cubic centimeter is equals to 1000 kilogram per cubic meter, or 1 kilogram per cubic meter is equals to 1 by 1000, means 10 power minus 3 gram per cubic centimeter. So these are the relations we have been calculated in yesterday's class. Am I right, guys? Everybody, please respond, all of you. So now, as we know, density of a substance will gives us the it is a characteristic property of a substance. So we can decide either a substance based upon the density. We can decide the object is either a lighter or heavier object. So now you can see, under a specified conditions, always remember the density of a given substance is always remains constant. So if I take iron, if I take the solid iron in Tamil Nadu, solid iron in Andhra, solid iron in somewhere, always the densities remain same. If I melted, then that is different. The density will changes. That is what I am saying. Under the specified conditions, the density of a substance is remains same. So after that, we studied the concept, call it as a next concept is what, everyone? Relative density. So relative density also we can call it as a RD. So what is the device which we are using to measure the relative density? Anybody? All of you? Hydrometer. So hydrometer is a device which we use to measure the relative density. So now you have taken relative density means, we all people knows what is the relative density, everybody? Density of a given substance. It is a ratio of density of a given substance with respect to what, guys? Everybody. Density of a, yes please. Density of a water at what temperature? Everybody. At 4 degrees Celsius. So when the water is having maximum density, anybody? Maximum density of water at what temperature? Everyone. At 4 degrees Celsius,
4 degrees Celsius.
which is 1 gram per cubic centimeter, and it is equals to 10 power 3 kilogram per cubic meter. Understanding? Means if I design a cube of each side 1 centimeter, if I design a cube of each side 1 centimeter, 1 centimeter, 1 centimeter, how many grams of water I can fill? Anybody? All of you. How many grams of water I can fill? 1 gram of water I can fill. If I design a cube of each side, how many meters? Agalya? Each side of a cube is how many meters? Everybody. 1 meter, 1 meter, 1 meter. In that, how many kgs of water I can fill? Everybody. 1000 kg of water. So that is the density basically. Clear, everybody? That is the water. So if you have taken, as it is relative density, both are density. That is what? Kilogram per cubic meter, kilogram per cubic meter. So units will get cancelled. So RD is a what? Everyone. RD is a what? No unit. It is the unitless quantity. So just it will gives us the information that either the object will sink or object will float in the given liquid based upon the RD. So RD is less than 1, then object will float above the surface. Clear, everybody? It will float above the surface of liquid. Surface of liquid or fluid. If RD is equals to 1, float inside, under the surface. Float under the surface of liquid. If RD is greater than 1, then object will what? Everybody? Object will sink. It will be settled down at the bottom of the liquid. That is what you have to remember. So, and one more thing keep in mind, the most important. As I said, maximum density of water is shown at what temperature? Everybody? 4 degrees Celsius. So, other than water, no other substance will be having this facility. Any substance, chemistry you studied that. Any substance, you can see, temperature increases, TEMP, temperature increases, keep it in mind, density will decreases. Understanding? Temperature decreases, density will increases. So, temperature is inversely proportional to density. This is the basic phenomena which is for every substance. Of course, it is for water also. But suppose water at 4 degrees Celsius, you can see water alone is a special. Water is going the temperature to 100 degrees Celsius. So density, temperature rising. Density will be what? Decreasing or increasing? Everyone. Temperature rising, guys. Decreasing or increasing? Decreasing. Clear? Now, less than 4 degrees Celsius, temperature decreases. Let me imagine 0 degree. Then density also decreasing. Basically, this is only shown by water. Water is having maximum density at 4 degrees Celsius. No other substance is having this one. That is why this property of water we used to call it as anomalous behavior of water. What we used to say, everybody? Anomalous behavior of water. Anomalous property of water. No other substance will show this. Clear, everyone? All of you understand?
Yes, sir.
So please make sure if anybody can ask me. Okay, guys? Yes. Niroshi, Nivedan, understood? Danishka?
Yes, sir.
So now, let us go with the most important concept. That is what Archimedes principle. So with this only, entire ship, boat, all the things is designing. So that is the principle we used to call it as a Archimedes principle or Archimedes principle. So let us see what is this principle and how to measure the Archimedes principle experimentally. That is what experimental verification of Archimedes principle. So let us take it, everyone. So basically, Archimedes is a Greek scientist. Who is Archimedes? Everybody? Yeah. So Archimedes is a Greek scientist. He found that when an object is immersed in a liquid, immersed means two. What is that, everybody? Partially immersed or two kinds of immersed. Partially immersed or it is immersed. Completely immersed. Do you understand it? Either it is partially immersed or it is completely immersed. Understanding? He found that whenever the body is immersed in a liquid, immediately it will experience some force. Anybody can tell what is that force, everyone? Yes, please. Any object, when an object, yes, when an
Violent force.
Yes, very good. So when an object is immersed in a liquid, Mr. Archimedes is observed that it is experiencing a buoyancy force. It experiences an upthrust. What do you mean by upthrust? Everybody. Upthrust also call it as, all of you, buoyant force. And also he has been found that what he found, let me see. All of you, for example, you are having a glass of water. Are you having in front of your home? So, okay, now all of you go to your kitchen just immediately. Take one glass of water, handle with carefully. All just topmost, till the topmost it has to be. Otherwise, take empty glass and then pour the water with the help of bottle. Everybody has to do it now. Make it quick, all of you. So you have to do it, but use some cloth, because again you spill it, your mother will kick. So please just careful. Okay. So now, shall we start, everyone? So as I said, whenever you jump into the water, you will feel lighter or you will feel heavier, your body. Everyone? Yes, please. Are you feeling lighter or heavier? All of you.
Lighter.
Lighter. That is because of what actually? That is because of buoyancy force or upthrust. So remember, he only found that a body is experiencing an upthrust or buoyancy force, and also it displaces the liquid. That is the thing is most important. Displaces the liquid. So what is this displaces the liquid? Let us understand. Now, anybody have you taken the water in our glass? Everyone, just fully up to the top. Now, just keep your finger, one single finger inside it. Have you noticed that some of the amount of water will spill out? Am I right, everybody? Yes, please. All of you?
Yes, sir.
Yes. If I put entire my hand, for example, I try to put all my 5 fingers. Is it more water will spill out or less water will spill out? Everybody, if I put complete hand. Yes, please.
More water.
More water. So, how much water will spill out? That is only Archimedes principle. We'll discuss it. So, this is only call it as when an object will immerse partially or completely. So, some amount of liquid will displace from that position. That is what it will displaces the liquid. That is the meaning of displaces the liquid. Liquid will move from that point. Some amount of liquid. How much it is? That is only the question now. So that amount of liquid, for example, I collected some amount of liquid here. So that liquid, the weight of that liquid is equals to the total weight of the immersed object. That is only the call it as what? Archimedes principle. So let us discuss now. When a body is partially or fully immersed, for example, see, all of you, if I take one beaker, understand everyone, I have taken a water, water, what is this everybody? I have taken a water. Now I dropped 1 kg stone. Now stone is completely immersed, partially ille. Now, because of this 1 kg stone, some amount of water will displace. That water I will collect in the another beaker. Now, if I measure this volume of the water, this volume of displaced water, which is equals to the volume of the object. Do you understand, Mr. Nivedan, what I'm saying, Lingesh? The volume of the displaced water, which is equals to the volume of this object, immersed object. Do you understand, guys? Everybody? And weight of this displaced liquid, if I calculate the weight of this displaced liquid, which is equals to weight of the immersed object, that is only basically we used to call it as Archimedes principle. So always keep it in mind, all of you write it. When a body is partially, for example, if I immersed in a glycerin, 1 kg stone or object, in this may be partially immersed. How much immersed? Everybody? Not say completely. Partially it is immersed. By the time also it will displace some liquid. Am I right or wrong? Everybody? Yes, please respond, guys. It is a glycerin. Yes. So now I will collect some amount of glycerin. This volume of a glycerin or the weight of this glycerin, the weight of this displaced glycerin, which is equals to the total weight of the body. It is partially immersed, doesn't matter. Whatever the weight of the liquid displaced by immersed portion of the body, either it is a partially immersed or it is completely immersed, which is equals to the total weight of the body. Do you understand, Laksha? Everybody?
Yes, sir.
Hiroshini, that is what you have to remember it. So this is the most important phenomena. So write it. Sam, understand Sam? Prithvi? So when a body is two kinds of, when the body will experience maximum buoyancy force. Yesterday I have taught you. When the body will experience maximum buoyancy force. Everybody? Partially
When it reach the
completely
bottom.
immersed. Partially immersed or completely immersed? Completely immersed.
Completely.
So when a body is partially or fully immersed in a liquid, okay, it experiences an upthrust, upthrust, whose magnitude is, what do you mean by magnitude? Amount. Whose magnitude is equal to the weight of the liquid displaced by the body. So that is only call it as Archimedes principle. The most important phenomena, whatever the volume of the liquid displaced, which is equals to the upthrust, that is only called as buoyancy force. So according to the Archimedes principle, upthrust or buoyancy force, buoyant force is equals to, which is equals to what, guys? Everybody? Weight of the liquid displaced. Purimara, Sam, Gokul, Lingesh, understanding? All of you? Or I said, for example, if air Mr. Nivedan, if I measure weight of Mr. Nivedan, weight of Mr. Nivedan on air is, for example, if I take, or mass, whatever you can take. So if you take weight, for example, he is above air. In air, he is 80 newtons. If I put him in a water, he may be turned up into 60 newton inside the water. So is it weight is decreasing or increasing? Everybody? Yes, please. Weight is decreasing or increasing? Decreasing. You understand? That is only we used to say loss of weight. We used to call it as apparent weight of the body. So that is the reason always we will feel lighter in the water or any liquid because of buoyancy force. So that loss of weight of the body, how much he lost from air to water, that is also equals to upthrust. Do you understand, everybody? So loss of, the weight of the liquid displaced is equals to upthrust, or loss in the weight of the body, that is also call it as a upthrust only. Okay, Shivani, clear what I'm saying? Mr. Pranav, Kishore, all of you, please
Yes.
respond. That is what you have to remember. So, sir, how to get this loss in the weight of the body? This loss in the weight of the body is only we used to call it as apparent weight. Remember, apparent weight, we'll make it, how to make it. So, how to get the loss in the weight of the body? So, formula you can see that loss in the weight of the body is equals to real weight minus apparent weight. So what do you mean by real weight? Anybody can tell? What do you mean by real weight? Weight of the body in where? Girls? Weight of the body in where, guys? Weight of the body in air is call it as a real weight. Minus. Apparent weight. What do you mean by apparent weight? Anybody? Apparent weight.
Weight of the
Yes. Weight of the body in what? Don't say water. We should use a word, call it as a what? Liquid. That is only call it as loss in the weight of the body, which is also equals to upthrust. I hope you all understand. Anybody having any doubt, you can ask me. Clear, guys? All of you? Yes, please. Respond, guys.
Yes, sir.
So please make sure any doubt you can ask me. Completed means then I'll proceed. Upthrust. What do you mean by upthrust, everyone? What do you mean by upthrust? Everyone. Yes. Upthrust means what? Weight of the liquid displaced or the loss of weight of the body. Whatever it is, your convenient, you can take it. No problem. Are you clear, everyone? Mr. Mukesh, Nivedan, any doubt you can ask me, Nivedan. Abhirami, understood, Kavya? Yes?
sir.
Yeah. So let us understand the Archimedes principle using the activity. Okay. So what is that activity? Let us see that. Very, very important. So if you want to find the Archimedes activity, you need an experimental setup. That is what is the experimental setup I am making. And you have to calculate the weight in what? Weight in air and as well as weight in what? Everyone? Nivedan? Yes, please.
Liquid.
Yeah. Understanding? Liquid. So experimental setup for Archimedes principle. 1 minute. Okay. So let us discuss that and you make you very clear. So you all will feel you can experience it also. In our lab also we can see and we can make it use of it. So just a minute, I am searching for HD picture. Okay. So I got it. Now you can even with the example you can experience it. So you can see all of you keep reading experimental verification of Archimedes principle. So this is the experimental setup. All of you check it, everyone. Experimental setup of Archimedes principle is very simple. Okay. So now first I have a block. You can picture A alone. You can see I have a block. Are you clear, everybody? I have a block and I measured with the help of spring balance. Why I am using spring balance here? I am measuring weight or massa. Anybody? I am measuring weight. Purima. So weight means what? Agalya? Weight means what? Force. Means it is a, what is the unit of weight? Everybody? Newton. Ellave Purima. That is. Now, I measured weight on air. I measured weight on air, which is equals to how much it is, approximately how many newtons it is showing. You can see example also I have given. Everyone tell me, what is that? Respond,
10
guys.
Newton.
10 Newton. Let me take that is W1. What do you mean by W1, boys? What do you mean by W1? Weight of body. Weight of the body in where? Weight of the body or block. Block in air. Now, I am taking a special setup. This beaker, not this beaker. Okay, this beaker. This, let me take, now I dipped into the water. I have taken water, but actually I should take it what here? Liquid. That liquid is, what is the example of liquid? Everyone.
Water.
Liquid, water. Understand, Amma? Girls, please respond. Everyone. Any doubt you can ask. Now, if I dip this in the water and if I measure the weight, how much it is showing? Check it, everybody.
6 Newton.
6 newtons. Purima, everybody. This is W2. What do you mean by W2? Everybody. Weight of the body in where? Everyone.
Liquid.
Weight of the body in water. Water means what it is actually? Liquid only. So, what is the loss in weight of the stone? Anybody can tell? Loss. Loss in weight of the
4
stone.
Newton.
Yes,
4
everybody.
Newton.
Weight of the stone, which is equals to, everybody, W1 minus W2, which is only equals to upthrust. Am I right, girls? Shivani, which is equals to upthrust. So W1 is 10 Newton, W2 is 6 Newtons. So what is the upthrust? Anybody can tell? What is
4
upthrust?
Newton.
4 Newton. So the block is experiencing how many Newtons of buoyancy force? Everybody. How many Newtons of buoyancy force? 4 Newtons of buoyancy force. This is normally. Now, another setup. What is another definition of upthrust? First definition. Another definition of upthrust. Make it quick. Another definition of upthrust. Weight of the liquid. Solunga thambi. Weight of the liquid displaced. Purima. Weight of the liquid displaced. Understand, Ara? That is equals to also upthrust. Correct or not? Adi theriyada? I've taught you or not? Check in your notebooks. Yes or no? Upthrust means weight of the liquid displaced. Am I right, guys? Everyone?
Yes, sir.
Yes.
Yes, sir.
So, for that one, So we have to collect the displaced liquid. We should not drop even single drop also, we should not lose. That is why I am taking a special container. See, this is beaker. This is called it as beaker. Now this beaker, if I make it a small modification for a special collection of liquid, that is what we used to call it as basically the small opening where the liquid, see up to here I will take the liquid. Understand, Shivani? So that is what we used to call it as a spout, and this design is called it as Eureka can. What we used to call, everybody? Eureka can. Understanding? So please note it. Eureka. Eureka can. So Eureka can is usually used to collect the amount of displaced liquid. Purima Nivedan. So now, if I put this setup, you can see, if I put with the help of a spring balance, then what will happen? As soon as that stone will go down, the block will go down, then the amount of water will start moving. Some amount of water. Is it entire water will come or only some amount of water will come? Yes, please. Some amount
of food.
yes, some amount of water will be collected. That water, let me take some amount of water I collected. Now, if I measure this, this is only call it as a displaced liquid. What we used to call, everybody? Yes, please.
Displaced liquid.
Displaced liquid. If I measure this weight of this displaced liquid, weight of this displaced liquid, that is also how many newtons coming? This is the displaced liquid. If I measure this weight of this, that is also how many newtons? Everybody. How many newtons I got it?
4 Newton.
Equals to upthrust. Understand, Lakshya? That is equals to upthrust. Purimara, Nivedan? Understand, everyone? So,
Yes, sir.
the loss in weight is because of, anybody can tell? The loss in weight because of, loss in weight is because of what? What force? Everybody. Because of what force, Ra? Very, very bad. Buoyant force. That is what you have to remember. Any doubt, anybody can ask. Clear, everybody? Yes. Lingesh? Doubt, Lingesh? Clear, Lingesh?
Yes, sir.
Okay. Kavya, this is only call it as Archimedes principle. Anybody having doubt, please ask me. Are you clear? Okay, guys? All of you?
Yes.
Yes, sir.
Okay. So this is the most important one. So you all should know. That is what I'm saying you. So experimental verification. So you no need to face any difficulty. It's the simplest experiment. You can conduct it in your lab, but you'll do or not, I don't know. But definitely I will show for some people. Okay. It is not black, it is body. Block, Laksha. I'm saying it is a block. Block means it's a body only, girl. Okay. I have written block. Purima?
Okay.
Yeah, block means one wooden block or stone or whatever you can take it. That's what they are saying, nothing else. Okay, ma? Clear, everyone? All of you?
Yes, sir.
Yes. So I think it's the easiest experiment. You all understand. Now we are going to study applications of Archimedes principle. And what is the name of this can, everybody? Name of this can, Eureka can. Okay. You want, you can put it in a Google, you will get it. Okay. Eureka can, you can see. Eureka can, you all can get it. This is what we used to call it as a Eureka can. So Eureka can basically we used to find the displacement of, collecting the displacement of amount of water. See that. If the stone will go inside, some amount of water is collected. That amount of the weight of this liquid, collected here, which is equals to what, everybody? Upthrust. Purimama, everyone. This setup is call it as, what we used to call, everyone? What we used to call? Eureka can. Okay. So please remember. And this opening of this Eureka can, we used to call it as a spot. Okay. So please make it. Okay. Shivani, understood? Now, we
Yes,
are going to study, take your book and you can mark applications of Archimedes principle. Application, this is what is the experiment, but even this is actually simplest experiment to observe the, okay, but it is Archimedes principle only, but I have made even more interesting. That experiment is very nice compared to this one. Okay, now you can see the next one is applications of Archimedes principle. Here you are having applications. So you can see many applications we have. This paragraph fully you can study, it will be okay. So it is used in designing a ship and submarines. So designing a ship and submarines, we are using Archimedes principle only. So based upon the type of sea, based upon the water in the sea, salt densities, everything is a parameters. We have to take it while you are designing the ship. Next, lactometers. So lactometers you will use in our daily life for testing the purity of a sample of milk. Purity of a sample of milk. We'll use this, the design of lactometers also based upon the Archimedes principle. Next, hydrometers. I already told you. Hydrometers is used for what? I already taught you, correct, guys? Hydrometers are used to find what? Everyone? Measure. Please respond. Density, relative density. Density kadayadu. Book they are mentioning density of the liquids. It is not density, Nivedan. What is that? Use it to measure the relative density. Determining relative density. Use a word, call it as relative density of liquids. Clear? All of you understanding? Huh? Please respond.
yes,
Yes. Next, Archimedes principle is used to determine the, okay, density as well as relative density. Both you can write it. Density and RD. Then it is okay. Okay. So next you can see all of you like this. You can take any boat. If you go to any village, small boat to big submarines, everything is designed based upon the Archimedes principle only. So that is what is Archimedes principle. Now, an important property of buoyancy I'm going to say you. So we are going to derive the formula for buoyancy force. Are you all okay, everybody? So let's start now. Formula for buoyancy force. I hope you all understand what is the applications of that. That is also will come in the exam. Write any two applications of buoyancy force. Sorry, Archimedes principle. Then by the time you have to write it. Will you all write it or not? Everyone? Agalya? Yes, please. Write it and do it. Okay? Okay, so let's start now. Everyone? All of you? So that is what we are going to see now. Please make a ding. An important property. Sam, understand as Sam? Abhirami? An important property of buoyancy. So this is the most important thing. We are going to make the formula for buoyancy force. So let us see, all of you. I will show you now, like you imagine that, all of you, I will draw 4 different images. Check it, everyone. 4 different images. Okay. 4 beakers I have taken. Now everywhere I have taken a liquid to the same height. You can take it, your choice. Okay. Now you see that I will draw objects whose object volume, different liquids, guys. Everyone, what is this? Different liquids. Are you clear, everybody? I am taking what? Different liquids. This liquid is different, this liquid is different, this liquid is different, this liquid is different. Now, I am putting the same object in this liquid, only very small amount of volume is immersed. Okay. Total volume is V. Immersed portion is V1. Okay, va? சொல்லுங்க தம்பி எல்லாமே ரெஸ்பாண்ட் அண்டர்ஸ்டாண்டிங். And second liquid, if I immerse, half of the substance is immersed. Then let me take that is V1. Now another liquid I immerse, complete object is immersed below the surface. You can see that immersed portion is V1. Now of another liquid is almost, it is ready to settle down. That is what V1. So these are the four pictures I am showing you. So please remember, immersed portion. What is the volume of the immersed portion? V1. Here also V1, here also V1, here also V1. In these two cases, partially immersed. In these two cases, completely immersed. So now remember all of you. So take a volume V and start immersing in a liquid of density D in a different liquids. First liquid, second liquid. Note it. Understanding? Different liquids. Different liquids, same object. Same object is immersing. So in this liquid, only very small volume is immersed. And here in this liquid, half of the object is immersed. Here completely immersed and under the surface. And here it is ready to settle down. So if you notice it here, Archimedes principle says that the buoyancy force acting in this body is equals to the what? Anybody? Is equals to the what? Just now I taught you. What is
Weight
the...
of
No, what is that? The buoyancy force acting in this body is equals to what? Weight of the nobody answer. Weight of the liquid displaced. Am I right or wrong? Please respond, guys. Weight of the liquid displaced. Are you clear? No response at all. Understand all of you? So when a small part of the object was submerged in it, imagine it will displace only little amount of water or any other liquid, correct? So it will displace us only little. So water level will rise us to certain height. Only it will displace us little amount of liquid. So let us take that little displaced liquid volume is V1. So which will be equals to the volume of the object inside it. That is what I am saying you. So keep it in mind, the volume of displaced liquid, is equals to the volume of immersed portion of the body. Note it, everyone. Immersed portion of the body. That is what you have to remember. Okay. So which will be equals to the what? Volume of the object inside the liquid, immersed portion of the body. So keep it in mind, if it is small, it is immersed very small now. So whatever the liquid displaced, understanding, the volume of that liquid is equals to volume of the immersed portion. Here half of the object is immersed. Now some amount of liquid will displace us. So if I measure this volume of this liquid, which is equals to this immersed portion. Nirosh, understand? Mr. Nivedan? Understanding, Ra? Now in this liquid, it
Yes,
will
sir.
displace us some liquid. If I measure this volume of this liquid, which is equals to the volume of completely immersed now, volume of the